Being able to generate these rows and columns is great, but I need to actually be able to put them in my matrix so that I can generate my entire spiral. The problem is that there's not really a great way that immediately comes to my mind on how I can figure out where to put these. So the reason is, if I start with just a 3 by 3 matrix, I start at 1 and work out to 9. This edge is the first row and first column, which is fine. Then when I add a column and row to the outside of this to get the 4 by 4, this is the bottom row and column, which is fine, and this is still the outside one. So in terms of looping through this, on the second time through, this is going to be the first row and first column, but only part of it. So notice that it has to stop short here. It has to stop there. And also the fact that it's the second iteration through this, but it's in the first position, is a little bit strange. And that's only going to continue getting more and more difficult as this gets bigger. So when this is a 5 by 5, well, now it's not the first one anymore, it's the second row and second column. And then if I add another layer around that, it's still the second row and second column. But again, only this little block of it. So what I need to be able to do is, for some particular n squared and some particular dimension square, I need to be able to figure out where to place this little block. So this is exactly what I want to do here. Knowing 25 or 9 or 4 or whichever square number I start with, I want to generate this block and then place it in the correct spot. So I need to be able to figure out where that place is. Now, as I said, I'm not really sure how I'm going to go about this yet, but what I want to do in the first place is just have a look on hand where these things actually go. So in the case of a 3 by 3, my first square number is 9 and the only other one is 4. So what I actually want to look at is the positions in the matrix of this or of these square numbers. And what I think is important is whether the number is even or odd, because one thing that I notice is I have to add 2 rows and columns to actually change certain things. So that's going to be based on the even or oddness of all this. So I'm going to keep track of all this and just have a look at where these square terms end up. What I'm going to do is track the position of the square numbers in my matrix for a few different dimension squares and see where they end up. And I'm also going to track the even and odd squares separately. The first one is test n is 3, and it is in the position of row 1, column 3. Then the next number is 4, which is test n equals 2, and then it's in the position of 3, 2, row 3, column 2. Then the next number is 1, and it's actually the only one left, and it's in the position of 2, 2. Okay, so now I'll check for a bigger square. So here n is equal to 4, and again I'm going to separate this into even and odd. Okay, so I've actually noticed something here, which is that for the even numbers, the row decreases by 1 and the column increases. And for my odd numbers, my row increases and my column decreases. So my first question is, does this actually hold for the previous test case, which was this one? There's nothing to check with the even numbers, but with the odd ones, the row increases and the column decreases. Okay, so it would be nice if in the next case, which is my 5 by 5, whether the same relationship holds. Okay, so we have a relationship here. So now if I know the square dimension, actually I don't even know the square dimension, but if I know the value of the square at this point, as I go through the available even and odd squares, I can know their position in the matrix. And if I know the starting position of this number, for example, then I can generate or place correctly these terms because they are all relative to the position of that value 16. Similarly for 9, 4, etc. So the only other thing I need to know is actually their absolute position for a given starting point. So I know relatively how these positions will change, but I need to know where the number starts. So in this case, the highest even value starts at n and 2. The highest odd number starts at 1 and n. So top right is 1n, and that will always be true. The even should always be bottom left 1 back, which will be n in the second column. So this should be always true for odd valued spirals. So the question is whether it's different for even valued spirals, such as this one. So this even value starts in the position of 4, 1, which is n1, which is bottom left, which will always be true. This odd one should start in 1 back from the end. So it will always be in the first row, and it will be in the n take 1th column, and that will always be true. So now we have two different cases for our even and odd size spirals. We know the starting position of the first square, and from that starting position we know how to change my indices to get to the next even or the next odd square.